Hello student, good morning. Today I am going to continue from the last class VSEPR theory, valence shell electron pair repulsion theory. Today I am going to discuss some explanation of shapes of molecules containing bond pair and lone pair. This question is very important and explanation is asked in many examinations like IIT, medical, UPSC also. Now I am going to discuss. First example, I am taking a type of molecule like AB2E. AB2E. E means here electron, lone pair of electron, one lone pair of electron. Then in this molecule, number of bonding pair is 4. SO2 is the example. In the SO2, number of bonding pair is 4 because 2 double bond is there. SO, SO, S is in the middle. And number of lone pair on sulfur atom is 1. Lone pair on sulfur atom is 1. And simply it is written as SO2. Its structure is bent. Shape you can tell it is bent, B-E-N-T. Now I am telling you explanation why it is bent. Whatever example today I am going to discuss, all are very, very important and difficult also. Why this structure, why this shape, I am going to tell you. Now, here just to listen, theoretically, the shape should have been triangular planar, but actually it is found to be bent or V-shaped. The reason being the lone pair bond pair repulsion is much more as compared to the bond pair repulsion. So the angle is reduced to 119.5 degree from 120 degree. Actually it was expected angle should be 120 degree. But due to this repulsion, their angle reduced to from 120 to 119.5. Okay, this happens due to the lone pair and repulsion between the lone pair and bond pair, bond pair repulsion. It happened due to that. Okay, then here the reason behind this shape, the reason behind this is the shape of bent. Why it is bent? The reason being the lone pair repulsion. Lone pair repulsion is much more, you can tell, not only more, much more as compared to the bond pair repulsion. Now I am coming to the next molecule, that is the type AB3E. AB3E. Example is NH3. E means, told you, lone pair, capital E, A-B-E, capital A, capital B, AB3E. AB3E. Its example is NH3. Then here number of bonding pair is 3 because 3 bonds are there, NH, NH, NH. And lone pair on nitrogen is 1 pair. Here again I want to tell you, in this case of SO2, on the middle, on the central atom on sulfur, it was 1 lone pair. But on oxygen, 2 lone pair of electrons were there. Each oxygen 2 lone pair. 2 lone pair because out of 6, 2 they have shared and formed the bond. On each bond, SO, then 4 electrons were remaining, means 2 pair on each oxygen was remaining. That's why repulsion was too much. Now come to the AB2E. Second example, that is the ammonia, NH3. Here number of bonding pair is 3 because 3 bonds are there, NH, NH, NH. And number of lone pair is only 1. And its shape is trigonal pyramidal. Its shape is trigonal pyramidal. Angle I told you 107 degree. Now I am telling you explanation. Had there been a bond pair in place of lone pair, the shape would have been tetrahedral. But one lone pair is present, and due to the repulsion between lone pair bond pair, which is more than bond pair repulsion, the angle between bond pair is reduced to 107 degree from 109.5 degree. Okay, due to this repulsion between lone pair bond pair, which is more than bond pair repulsion, the angle between bond pair in a bond pair is reduced to 107 degree from 109.5 degree. Okay. Now I have already attached this sheet for these molecules. You can see in video. Now third example, that is AB2E2. AB2E2 means here E2 means 2 lone pair is there and bond pair is 2. Example is water, H2O. Example is H2O, water. And its structure is shape is bent. Its shape is bent. Now explanation I am telling you. The shape should have been tetrahedral if there were all bond pair, but 2 lone pair are present. So the shape of distorted tetrahedral or angular. The reason is lone pair repulsion is more than the lone pair bond pair repulsion, which is more than bond pair repulsion. Thus the angle is reduced to 104.5 degree from 109.5 degree. Again one more time I am telling you because it's very all are important only. Here in H2O 2 lone pair is there and 2 bond pair and its structure is bent. Now listen explanation. The shape should have been tetrahedral if there were all bond pair, but two lone pair are present, so the shape is distorted tetrahedral or angular, you can tell. The reason is lone pair repulsion is more than lone pair bond pair repulsion, which is more than bond pair repulsion. Thus the angle is reduced to 104.5 degree from 109.5 degree. Now come to the another example, AB4E. AB4E. Here example is SF4. SF4. In this SF4, 4 bonds are there. Number of bonding pair is 4 and lone pair is 1. See the structure I have given. Then here 2 structures are possible. Both are SF4 only, but there is a little different in shape. 2 structures are possible, I will tell both, and minor change is there in shape. Its structure is known as CSIR, SEESAW, CSIR structure. Now explanation we can say for the first structure. That is, you can tell structure A, structure B. Then I am talking about structure A, first structure. Means 2 structures are there, then both you understand. Then first you understand first structure. Then in first structure, the lone pair is present at axial position. Axial, AXIAL. This is the main things I am telling you. In first structure, the lone pair is present at axial position. So there are 3 lone pair bond pair repulsion. Again you listen. In first structure, the lone pair is present at axial position. So there are 3 lone pair bond pair repulsion at 90 degree. This is the main things. In other structure, means B you can tell. In other structure, the lone pair is in an equatorial position. Equatorial position. Lone pair is at an equatorial position, and there are 2 lone pair bond pair repulsions. In the first there was 3 lone pair bond pair repulsion, and in the second structure only 2 lone pair bond pair repulsion. Hence arrangement in the second is more stable. The shape of the second as a distorted tetrahedral. The shape of second that is described as a distorted tetrahedral, or you can tell a folded square or a seesaw structure, SEESAW, seesaw structure. Then that I have told you difference between the two structure. In first you can say that lone pair is on or at axial position and have 3 lone pair bond pair repulsion, but in other lone pair is at equatorial position and there are 2 lone pair bond pair repulsion. This is the only difference. Now one more example I am telling you. that AB3E2 molecular type is AB3E2 means here two lone pair is there. An example is ClF3. Here number of bonding pair is 3 and number of lone pair is 2. Chloride is in the middle and 3 chloride ion is in the middle, chloride atom is in the middle and 3 bonds are there, ClF. Here 3 structures are possible. Here 3 structure in SF4 there was 2 structure. Now here there is a 3 structure possible, but number of bonding pair is same and number of lone pair is also same. Means number of bonding pair is 3 means 3 bond and number of lone pair is 2. Now arrangement actually 3 type is possible. In the last case 2 was there, now here 3 possibilities there. And shape is called T-shaped. T alphabetical letter is not T, that T shape. Now just understand the reason for the shape. Then you can tell 3 shapes are there, A, B, C like that, or 1, 2, 3, anything, 3 are there. Then first I am talking about the shape of first arrangement. Then here in the first case, the lone pair are at equatorial position. So there are less lone pair bond pair repulsions as compared to other in which the lone pair are at axial positions. That is the main difference. So the structure means first structure is most stable, T-shaped. That is the difference between the out of 3. First I am talking about the lone pair are at equatorial position. So there are less lone pair bond pair repulsions as compared to others. That is the main difference. In which actually in others I am talking about that in others lone pair are at axial position. In both cases other 2 lone pairs are at axial positions. So a structure means first structure is most stable, that is the T-shaped. Okay, minor differences are there. In first case that lone pair are at equatorial and at the others, in others too it is axial position. That is the difference. Then today I am stopping only here, and next class again I will discuss valence bond theory. Okay, thank you.